Used to get to do it in lab. I think some labs still do, just don't have the chemicals for it. I know, it'd be pretty cool, wouldn't it? So when we begin to look at having these antibodies, the anti-A, anti-B, okay, having the ABO blood type, it usually shows up about 2 to 8 months after birth is when your blood type is going to show up. You have a maximum concentration roughly around 10 years of age, mainly because every single bone in a child's body is producing red blood cells. Have you ever been around children growing? My grandchildren, 10 and 8 right now. And it's like all I hear, I'm hungry, I'm hungry, I'm hungry. You just ate. I'm hungry. You just had 4 slices of pizza, salad, and dessert. I'm hungry. They probably are, because their bodies are busy, all right? They are in constant production. So I feed them. So this is huge, okay? As we reach puberty, get to our full growth, 18 to 22 years of age, all this stuff is going to begin to slow down, all right? Now, these antibodies that are found in the plasma, you're not going to form under normal conditions. You are not going to form antibodies against your own antigen. That's the hope, okay? Things, however, can go wrong. If there is something that goes wrong, we get the production of the antibodies. Note, the antibodies make those red blood cells stick together, meaning they agglutinate, they clump. So, agglutination, antibodies, they can attach to several red blood cells. This is responsible for transfusion reaction. The agglutinated red blood cells block those really small blood vessels, hemolyze, break the red blood cell apart, they release their hemoglobin, and basically we get a blockage to the kidney tubules, leading to renal failure, which is going to lead to death with a mismatched transfusion reaction. So let's say we have person with type B. Type B is not going to have anti-B, it's going to have anti-A, because if they're given A, it wants to make sure that it kills the A's, not the B's. So we're going to find that donor blood was A, but the person's B. Body's going to say, whoa, 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 this is wrong. Antibodies are going to come in, they're going to attach, we're going to clump, and we're going to block our blood flow. And toodaloo, it's all over. Type O is considered the universal donor because those are going to be the red blood cells that are most likely, note my terminology, most likely not going to cause a reaction. Giving them packed cells means there's very little plasma and therefore chances decrease for any type of antibodies. So type O is considered universal donor. And I think if you're O negative and you like donate blood services is going to be calling you all the time. Yes, they want you giving blood I think, what is it, 6 months? Every 3?
They call you no matter what, every 6 months. If you donate blood, they'll call you every 6 months. Be positive every 6 months.
And I donated it, and they sent me my card back, and they're like, next time you donate, make sure to tell us your image so we can, like, take more blood. And I was like, I'm not going to donate. Because they were like, there's universal donor.
Oh yeah, they want your blood.
Yeah.
Yeah. They definitely want that. The universal recipient is the person who has AB, but that's very rare. Okay, that's not as prevalent as the other blood types because there are no antibodies. So therefore, they could be given A, B, AB, or O. But there's this other thing we got to deal with on those red blood cells. Are you positive or are you negative? Do you guys remember, what's his name, talking about this? Okay. Discovered in the rhesus monkey, so therefore the RH, all right. Now, the RH, C, D, and E, these are agglutinogens, not good, all right. RHD, rhesus factor D, that's the most reactive one. If you are considered to have RH positive blood, most likely it's the D antigen that's going to be present. RH frequencies are going to vary. The RH plus and negative, that is where we have, that they've done a lot of the research trying to determine there is an exact match from recipient to donor. Even to the point of where if we look at giving or donating organs, all right? Some of the stuff that they've actually had to, that they've actually discovered now, like with donating organs, they've actually discovered it down to the actual proteins on the membrane of the cells. So the recipient and the donor, the more match they can actually get, the better their chance of the body not rejecting the donated tissue, which is kind of cool. Take a break. Be back at 9:30.